Hello guys, welcome to Bugs in Code, and the problem that we are going to solve today is minimum distance between any two BST nodes. Okay, so the problem is present at Leetcode. I'm even going to provide the link in the description box. But before that, if you're new here and a person who likes stuff related to coding, then you can subscribe my channel, that is Bugs in Code, and so that you never miss out an update whenever I upload my new video. Okay, so let's get started. The problem statement says that given the root of a binary tree and binary search tree, return the minimum difference between the values of any two different nodes. Okay, so like we can have the difference between these 4 and 2, which is 2. We can even have the difference between these 2 and 6, which is 4. Like this 4 and 6, we are going to have difference, which is 2. Similarly, for this we are going to have difference 1, and similarly for this we are going to have difference 1. So these are the possibilities. There may be more possibilities as well, like we can have difference between these two, which is 2, and among all of the differences I need to return the one which is smallest difference. So 1 is going to be our answer here. Okay, so I hope you get the clear understanding. Let me even take one more example. So let me draw a binary search tree here. Like we can have this tree, and even let's do something like, okay, so now we can have data in this binary search tree like 5, 7, 9, 11, 13, and 19. Okay, so now we can have various possible differences between different nodes. Like these two have a difference of 2, so 2 can be one possibility. These have 6, and even this 7 and 19 has a difference of 12. And after that we have difference 2 here, we have difference 2 here, and 11 and 13 we have difference 2 here. Let me see whether we have more possibility, or like 4 can be one more possibility. That's the difference between these two nodes. After that we can have one more 4, like this 11 and 7. So these are the set of possibilities, and out of all these possibilities we need to return the smallest. So here 2 is the smallest difference between any two nodes, so 2 is going to be my answer. Okay, so I hope you now get the clear understanding of what the problem says, and let me move to the solution. Okay, so the first thing that comes to my mind after looking at this problem is, let me draw the tree again. So we have a tree like this. We have 5, 7, 9, 11, 13, and 19. Okay, so now what we can do is, we can, since this is a binary search tree, so a binary search tree always store the value smaller than 11 in the left subtree, like smaller than root, and greater than root in the right subtree. So this property is going to help us. Why? Because if I store the in order traversal of this binary search tree, then I'm going to get sorted nodes like 5, 7, 9, 11, 13, and 19. But you may ask, what is the use of sorted order here? So sorted, or the use of sorted or order, we are going to get benefited by this. Like the smallest difference will always be the small difference between two adjacent nodes. So like 5 minus 7 has the difference of 2, 7 minus 9 has the difference of 2, 9 minus 11 has the difference of 2, and 11 minus 13 even has the difference of 2. And now 13 and 19 have a difference of 6. So out of all these possibilities, we have the smallest difference as 2. So what we can do is, we can have a set of steps, like I can store the in order traversal, and after that I can traverse the list, which stores the in order traversal, the list, and minimize the difference. Okay, so I hope you know how to get the in-order traversal of a binary search tree. And if you don't know, then let me know in the comment section. I'm also going to make a video on that. Like in-order traversal is something that have like various ways to perform in-order traversal. So let me now code the approach here. So let's remove this. So this is a problem in lead code and we are going to code this problem. Okay, so I will have a list of integer here that is going to store my in order traversal, and it will be implemented by array list. Now I have to call a function that is in order, that is going to take my root and also in order to store the in order traversal. Okay, so now uh, here let's take we got the in order traversal. So what next we are going to do? We are going to have a variable that is min, and initially it will have the max value. After that, what I will do is I will traverse the whole list, like I smaller than the size of list. So what we need to do is we need to minimize the difference. So the difference is going to be min and the current element and the previous element. So this is something that I am going to write. But there is a problem in this approach. The problem is we need to start from 1, because for 0 it is going to throw me an error which is error index out of bound, because I minus 1 will be minus 1 in case of 0. Okay, so I have not written the method yet, so let me write the method in order. So this method is going to take a tree node root and a list of integer which is in order. Okay, so if my root is equal to null, I'm just going to type in order traversal without explaining much. So if you guys don't know, then you can let me know in the comment section, and after that I'm going to call the in order function for left, and similarly we can call the function for right children, and after that here we need to store the value of current root. So this is our in order traversal, and now I just need to run this approach. Like I'm done with coding. Okay, so it's showing me error here, list of integer is going to be my new error, list of integer, but actually it's showing. Okay, so I have not written new here. Let me run this approach. It should work now. Okay, I need to write here add. Let's see whether it works now or not. Okay, so it's working now, and let me just submit this approach. Okay, so it's working, and it's 100% faster than all the Java Online submission, but space is something that I'm not satisfied with. Here you can see that I'm using extra space, like in order traversal, in order to store this traversal. But what I'm thinking is we can do something better. What we can do is, now let me talk about optimization. So I need to show you, let me just write optimization. So here if I show you, then I have 5, 7, 9, 11, 13, and 19. So let me separate this. Now if you notice that each time we are just making the use of one previous element instead of the whole array. So what I'm saying is, why to store all the elements? Like if I'm at 7, I just need to store this previous element 5, and after that when I will move here, then I'm going to store this 7 as a previous element. So 5 minus 7 is going to be 2. After that my previous becomes 5, so I'm going to make use of one variable that is previous. And now whenever I will move ahead, so I'm going to store the current element in the previous variable. Okay, so now just let me just code this approach. I hope you got the understanding what I'm trying to say. So I will have a previous element which is storing the previous element of the in order traversal. So while doing the in order traversal, let me just code this approach as well. So while doing the in order traversal, we just need to have one element that is going to be your previous element. And let's remove this. We are not going to make the use of this, and even remove this from this parameter. After that, I will make it a reference variable, and I'm going to pass it in the function, because here I'm going to calculate my answer instead of the in the same function. So I will have a reference variable here. After that, I need to initialize my previous. So I'm initializing my previous with -1, because for the first node I don't have any previous element. After that, I don't need to write this much. Now just this is something that we are going to do in the node traversal. Like here we have the node. So what we are going to do is, we are first going to check whether my previous is equal to -1 or what. Because if my previous is -1, then we are not going to have the answer. Else we are going to calculate the minimum of the current answer and the difference between root and previous. So this is something that we are going to do. After that, when we move a root, so we need to store our current root value in the previous variable. So now I think I'm done with the approach. I just need to return minimum of 0. So this approach is using just of one space. And let me, okay, so I need to improve this as well. Okay, let me see. Now I think it should work. And okay, now it will surely work. And my god, I just need to remove this part, and I have to write it here. Okay, so now it's working, and let me just submit the solution. Okay, so this is the second approach that we have done, and we have optimized the space here, but still I don't see any improvement. But still, this may be because of the bug in Leetcode. So this is the approach, and you can see here we are just using off one space. So that's what the approaches are. And if you like the video, then you can hit the like button, and till then, stay tuned. Thank you.